All right, guys, thanks for coming in on a holiday. We got extra cookies today because more people are on Zoom than normal. I'd like to take a minute and introduce my good friend, Alicia Moss from Alabama A&M. She's originally from York, Alabama. If you don't know where that is, it's not the edge of the world, but you can see it from there. It's out in West Alabama. She did her undergraduate at Alabama A&M, a PhD at Michigan State. She's completed a certification recently in epidemiology from Johns Hopkins. And she's also done a lot of work in the local area with Africatown on some water quality stuff. So if she doesn't talk about it today, it might be something to ask about during the Q&A session at the end. So without further ado, Dr. Moss, please.
Thank you to Lee, and thank you all for coming today. So I'll go ahead and get started. So the title of my presentation is Escherichia coli, the relationship with land use, seasonality, and physiochemical parameters in the Tennessee River Tributary. Okay. The paradigm in assessing water quality includes the concept and knowledge that microbial indicators is crucial for the protection of ecosystem health, for accurate risk assessment, and for the remediation of water bodies with impaired water quality. Most states, including Alabama, monitor for total coliforms, fecal coliforms, E. coli, fecal streptococci, and enterococci as indicators of potential pathogens in water resources, which help identify these public health risks. So these fecal indicator bacteria and other microorganisms are ubiquitous in both terrestrial and aquatic ecosystems. And as such, the bacterial contamination is a major concern for the protection of the nation's water. So the presence of E. coli, which is a type of fecal coliform, is commonly found in the intestines of animals and humans and is a strong indication of the recent sewage or animal waste contamination. Research has shown that the common sources of the potential pathogenic contamination in surface waters include storm runoff from urban and agricultural landscapes, wild animal waste, wastewater treatment plant discharges, and then failing septic systems discharge. And so Alabama has long been recognized for its beautiful and abundant water resources. There are over 129,000 miles of perennial and intermittent streams and rivers, 425,000 plus acres of publicly owned lakes and reservoirs, 610 square miles of estuaries, and 337 miles of coastal shorelines, which includes bays and inlets. Section 303 of the Clean Water Act requires that each state identify those waters that do not currently support these designated uses. And this is done to establish a priority ranking of these waters by accounting for the severity of the pollution and the designated uses of such waters. This list includes segments of rivers, streams, lakes, reservoirs, and estuaries that do not fully support these designated land uses based on the chemical, physical, and biological data that's collected through the water quality standards. And this includes the E. coli levels exceeding the 5-day geometric mean of 126 colony-forming units per 100 milliliter. So Flint Creek is one of Alabama's precious natural resources, and it provides recreation to many anglers, canoeists, kayakers, hikers, photographers, and other wildlife observers, and also supports the research and the development that's associated with this expanding space and the missile rocketry that we have in North Alabama. It's identified as being impaired and classified as category 5 on this 303D list. And the segments between the Flint Creek watershed, which are part of the Tennessee River Basin, has a long discharge area of 455 square miles that covers approximately 291,000 acres. So in the past, the elevated levels of the waters in the Tennessee River Basin have met the guidelines for federal and state as it relates to drinking water quality and the protection of aquatic life. However, agricultural activities have affected this water quality as indicated by the elevated concentrations of bacteria, nutrients, pesticides that have been found in streams and rivers. And so the creek is listed as a priority water body for agricultural non-point source pollution, because although some sections are wild and undeveloped, the upper reaches of the creek drain agricultural land that's comprised of livestock, poultry, and then row crop farms. Several concerns have occurred within this watershed, and they include the application of biosolids, which are often linked to the contamination in these aquatic systems by pathogens. Also, pharmaceuticals and other endocrine disrupting compounds. And so we've done some work looking at mercury in these water bodies in that area. And so there have also been concerns with agricultural lands, as mentioned, that have the potential to migrate off-site via surface water runoff and or leaching and then pose harm to these aquatic ecosystems. Many land uses that impact the water quality are agricultural areas within the watershed as well as urban areas. And so since the 1950s, the non-point source pollution has plagued Flint Creek. And so the overall surface water quality within the watershed has been designated as fair to poor. And this led the EPA to adopt Flint Creek watershed as one of its pilot watershed studies. So the major thesis of this study is that water quality assessments conducted indicated that 102 streams throughout the lower Tennessee River Basin are impaired for recreational uses because of elevated levels of E. coli. So for this study, streams in the watershed were selected based on their drainage and proximity to animal feeding operations, also agricultural land, urban and forest land use areas within this range. Specifically, E. coli prevalence has been shown to increase with summer months and then trend negatively with precipitation. And this is what we often see in a lot of studies. And so the subsequent positive effects of temperature and precipitation also correlate well with elevated E. coli levels in the spring and the fall. There have also been studies that have found that land defined as urban and agriculture were correlated with pH, specific conductance, and rainfall, which tended to impact the density of E. coli. So the objectives here were to determine the seasonal variability of E. coli and which is the fecal indicator bacteria, detect possible relationships between managed land use areas in relation to the presence of E. coli, and then identify the physiochemical parameters that may serve as drivers for the presence and density of E. coli within each land use area. So description of the study site. So the Flint Creek watershed, which is located in the Tennessee River Basin, has the total drainage area, as mentioned, of 455 meters squared and over 1,600 kilometers of perennial and intermittent streams. The predominant land use area is agriculture, pasture, and forest, and the geology consists primarily of Tuscumbia limestone. It originates in Coleman, Alabama, and flows into 17 segments of impounded waters of Wheeler Reservoir on the Tennessee River. And so one of the segments, Flint Creek, within the watershed, stretches for 6 kilometers and was used for this study because of its designated uses for fish and wildlife, public water supply, and limited warm water fishery. The major causes of impairment in this watershed are organic enrichment, dissolved oxygen, nutrients, pathogens, and siltation. The sources of this impairment include municipal point sources, non-irrigated crop production, pasture grazing, intensive animal feed operation, and urban runoff and storm sewers. And so this figure shows the land use distribution within the Flint Creek watershed. And so I can't see the thing. So, but here you see that the forest land use is the most dominant at 46%, then agricultural together is 40%. And then here at the top is urban at 2.5%. And so those are the three land uses that we'll be looking at today. And so the analysis was conducted on 3 sites of the Flint Creek watershed. The first named Red Bank Road, and this is a forested system. So there were, it's mostly forested areas. There's expanded residential construction. There's a horse pasture there. The second is urban area, which is of course mostly urban, is right off the highway. There's evidence of people dumping trash, illegal drug dumping, and also the gas from nearby boats that are there. And then the last is the agricultural land use area, mostly agricultural with cattle and goat farms, in some residential areas there as well. And so for here, we have 6 samples, again, that were taken in triplicate monthly at the 3 sites. So for the enumeration of E. coli and the physiochemical parameter analysis, we use the IDEX call alert test at 35 degrees for 24 hours. And the geometric mean of the E. coli concentrations were calculated using the most probable number method for each month studied. The US EPA criteria is the 5-day geometric mean of 126 CFU per 100 milliliter was the standard in determining whether these sampled waters where the E. coli counts were safe or unsafe. And this geometric mean was used to calculate the central tendency where a large group of numbers may vary. And so we used the YSI multi-parameter sonde for the real-time analysis of these physiochemical properties. We looked at pH, dissolved oxygen, specific conductivity, and temperature. And so regression analysis was performed in order to identify which environmental parameters or predictors were significant in predicting the relative abundance of E. coli counts within the Flint Creek watershed. Pearson's correlation coefficient was performed to determine the relationship between the concentration of E. coli and the physiochemical properties across and within the Flint Creek watershed. And the Pearson's correlation coefficient was used to determine the overall direction, the nature, and the strength of the relationship between E. coli and these different land use areas, and then E. coli and the physiochemical properties. Probability value was calculated to determine if those relationships were statistically significant at p equals negative 0.05. And so if statistically significant, then there's evidence against the null hypothesis that things happen at chance, as there's less than a 5% probability that the null hypothesis is correct and that these results were random. And so the linear relationship was then assessed by scatter plots to identify the possible thresholds in relationship between E. coli and these environmental variables. So each of these differently managed land uses here have the potential to contribute to the organic loading, because organic matter on these land surfaces have the tendency to wash into the streams and then thus cause or affect the overall quality of the water and the watersheds. And so here you'll see the analysis too of the physiochemical properties of the pH, specific conductivity, dissolved oxygen. And so the pH range is usually between 6.94 and 8.6 or so. And as you can see, all the waters that are tested here in each of the land use areas fall within that pH range. We'll look at specific conductivity, which has a range of 50 to 1500 microsiemens per centimeter. Then none of our samples are outside of that range, but literature shows that with the increase in temperature, you have an increase in specific conductivity. And so even though they were, the samples were not outside of that range, there was an increase in the specific conductivity in some of the summer months when the temperature was higher, but it's not always the case. And one of the things that we'll see here is that a lot of these results don't necessarily follow all of the what's out in the literature, just, the E. coli concentration has been higher in the summer, or specific conductivity having that relationship with temperature. And then also dissolved oxygen, which usually is lower during the summer months or with increased temperature, because as literature states, higher E. coli levels, and then dissolved oxygen would be lower. And so that's the case in some instances. Okay, like some instances here, but then the temperature is not necessarily the highest temperature. So it varies. And then it's consistent. Well, I will say this, it is consistent across all land use areas, but not necessarily overall when we're looking at, the study. And then with E. coli, we use, like I mentioned, the most probable number method. And then we calculate the 5-day geometric mean of the 6 individual samples that were taken in triplicate monthly. And from here, we see that number one, which may be totally evident, is can't get this right, but right here, where you see this is the largest level of concentration of E. coli that was measured throughout, and it was in the urban land use areas. And so, with this, we're saying that it may be, skewed a little. It may be because, fecal indicator, the fecal bacteria from the fish may have been elevated, at this time, but we don't know, for sure. And so that is kind of an outlier for this sample. And so one of the things we'll also notice is that the high levels of E. coli were in the spring and the summer months. And then also we saw in September of each year, and this was consistent among all 3 land use areas. And so it is typically warmer, in Alabama in September too. So that could be the case there. And so, but we would see these elevated levels, like I said, in the spring, summer, and the fall. And then the winter months, when of course, typically the E. coli levels would be lower, which they are here in January and February. But we also saw lower levels of E. coli in June and July when the temperatures were higher, right? So, and it's not like, say here, where it's an outlier like the higher level E. coli here. It was consistent among all land use areas that those low levels of E. coli in the summer months. So all these results, basically, they confirm and contradict a lot of what's in the literature, because it doesn't follow the normal, range of E. coli being higher in the summer, just in the summer months. And so we saw variations in that. And then also there were seasonal patterns when looking at the E. coli in the watershed that surpassed the 5-day geometric mean of 126 CFU. And those are in the blue here. And again, it was relevant in the summer months, but then also in September. And one of the things that we'll notice too is that the urban land use area had the most instances where the E. coli exceeded that EPA recommendation. And so here's just a graph looking at those same results, but just the E. coli in the different land use areas and temperature. So here you see where The low levels of E. coli were, when the temperature dipped, but then we also see the low levels here when that temperature was significantly higher. And then that outlier here in the urban watershed. All right, so seasonal patterns of these indicator bacteria often differ with the different land use areas, because runoff from forested and pasture lands tend to wash off into the streams during storm flows. And so the most dominant land use area here, again, is the forest, followed by agricultural, and then the urban watershed area. And so we also see that looking and then breaking it up in spring, summer, and fall, but overall through the year, when we're looking at these average seasonal concentrations in these different land use areas, we see that urban overall, and it's taking into account all the E. coli levels, was higher, followed by the forest land use area and then the agricultural land use area, which per all the literature is a little, it's not in line with the literature, because you would think agricultural land use area with the animal feedlots and all that, then you would see these elevated E. coli levels, but it's not necessarily the case that we found here. And so, but there have also been studies that have seen elevated levels of E. coli in urban land use areas as well. And so, as I mentioned, the agricultural land use areas, these animal feedlots, are usually the main characteristics in watersheds for elevated E. coli levels. So Pearson's coefficient, correlation coefficient, and the p-value data were also calculated to identify these possible relationships between the managed land use areas in relation to E. coli, and to determine if there was any significance in these relationships. So the degree to which the specific land uses are designated within a catchment can serve as an indicator of the possible water quality impairments or impacts, because of the strong relationships between the land use activities and non-point sources of pollution. And so a study concluded that fecal indicator bacteria is usually significantly correlated with both agricultural and land use covers. And then when compared to other land uses, organic enrichment from forested land is minimal, because the forests tend to act as a filter for sediments and other organic material, and therefore does not express a strong relationship as it relates to E. coli. And so here we see that from the statistical data that there are positive relationships in relation to E. coli in each of these watersheds when compared to each other. However, the strongest relationship is the E. coli in the agricultural and forested lands, and it is the only relationship that is of any significance. So from looking at the data here, and then also thinking back to when we talked about the levels of E. coli being higher in the urban land use areas, it can be interpreted to mean that, or to say that the higher concentrations of E. coli in the urban land use areas tends to weaken the relationship when compared to other land use areas. Because like here, when it's not in the picture, then that's when you have the strongest relationship, because the numbers are closer to each other as far as the higher E. coli levels. And so here is just the linear regression showing the relationship between the E. coli and the different land use areas. And again, they're all positive relationships, but the only one of significance is the forest and the agricultural lands. Is closer to that regression line. So there's not a lot of disturbance or distance between those numbers. And so in the past, there's also been reported water quality issues related to the variations in physiochemical levels in heavy metal concentrations and then in organic compounds in this Flint Creek watershed. And so this study looks at the relationship between E. coli and the physiochemical parameters in the multiple land use patterns. So here we see that with the dissolved oxygen at pH, then all the relationships, so it's negative relationships there. So basically the pH and the dissolved oxygen don't really have an effect on the E. coli levels. And then looking at these relationships, although negative, in the urban land use area, this is the only one that's of significance. And then in the pH, in the agricultural system is the only one that is of significance. So a high variation in those numbers. And then we look at specific conductivity and temperature, and these are the only two parameters in this case that displays a positive relationship or has an effect on those E. coli levels. However, none of these relationships, even though they're positive, are significant, right? And so so the results here are consistent with studies where you're looking at indicator bacteria and watershed dynamics, which list both site and temperature as having or being an important predictor of E. coli. So we see that case here when we look at temperature, and then here also on the specific conductivity. And so here again, looking at those linear relationships, and again with pH negative relationship, and then the same with dissolved oxygen, and then the positive relationships or correlation with in relation to specific conductivity and temperature. Okay, so those determine or the temperature and specific conductivity help determine or have an effect again on the E. coli levels in this particular watershed. And so determining the presence of E. coli and potential correlations to differing land use areas and physiochemical properties have provided substantial insight into the public health of this watershed. And so the information obtained here will hopefully assist in managing possible risks to human and environmental health, and in the essence, improving environmental sustainability. And so the E. coli levels in each land area were higher in the fall, followed by the spring, the summer, and then the lower concentrations during the winter in most cases. And so the most impaired waters were in the urban land use area, as evidenced by the number of times sampled that exceeded the EPA's threshold. And so one of the things that here that we want to do is continuing to manage or to look at this watershed to see if this is consistent, all the time, because again, it does not follow the literature where, we're thinking that the higher levels of E. coli would be in the agricultural land areas versus the urban areas. But we do know that there can be a lot of runoff in these urban areas from these construction sites and things like that. So that may also contribute to that area. And then where we sample is in near Decatur. And so there's a lot of companies that tend to dump things in water, and that tends to run off or leach into the water too. So that may also be a factor. And so the relationship between the E. coli concentrations in the agricultural and forested land use were the only exhibited significant relationship. So taking into account the findings garnered from the enumeration of E. coli with each land use, then these results can be interpreted to mean that higher concentrations of E. coli in urban land use may weaken the relationship when compared to these agricultural and forested land use areas. And then these results also found that the drivers for the determination of E. coli were temperature and specific conductivity, both of which had positive correlations in each of the 3 land use areas. And so further research, again, with more sampling data points will need to be analyzed to determine if these are factual assertions and could they be found in other settings. So these results also illustrate the need for improved understanding of E. coli prevalence and persistence that possibly through microbial source tracking in the environment. So then I was making the, the assumption that maybe, some of the construction from the urban areas may have been the case, but then we do the microbial source tracking and determine, exactly what are the contributing factors, because in the Flint Creek watershed, even the urban land use area had a small farm near there, right? But it's not like wouldn't be deemed an agricultural land use areas. So is that one small farm contributing to the high levels of E. coli? So that type of information we would garner from the microbial source tracking studies. And so also equating the E. coli levels with activity usually specific to particular land uses highlights the difficulties in managing and regulating bacterial contamination of surface waters. Here's a slide. And so I would like to thank Dr. Lee Smee for and everyone here at Dolphin Island for the invitation to come and present, and then for the possible research that we will all do together, maybe in the future. I look forward to that. The Environmental Health Science Program and Environmental Chemistry Program at Alabama A&M. We also have a Center for Excellence in Watershed Management at A&M, and the National Institute for Food and Agricultural Sciences, NIFA, with the USDA for funding for this grant. So I want to thank you all again, and at this time, take any questions.